Hi, my name is Petrus Cyril Mawan, anak Simon Julai. My matrix number is 73784. I am the first year student from the Department of Mechanical Engineering and Manufacturing in UNIMAS. In this video, I will talk about the basics of thermodynamics, laws of thermodynamics, and application of thermodynamics in the electric chuck kettle. Let's find out more in this video. First of all, we need to know where does this thermodynamics terms come from. Thermodynamics come from Greek word therma, which means heat, and dynamics, which means force or power. Basically, thermodynamics is the study of how heat, work, and energy affect a system. Okay, now I will explain to you briefly about laws of thermodynamics. Firstly, Zeroth law of thermodynamics means that if two systems are both in thermal equilibrium with a third system, then they are in thermal equilibrium with each other. First law of thermodynamics is basically the thermodynamics version of law of conservation of energy. Second law of thermodynamics indicates the irreversibility of natural processes and in many cases, the tendency of natural processes to lead towards spatial homogeneity of matter and energy, and especially of temperature. We will emphasize more on second law of thermodynamics because the application will use this second law of thermodynamics. The third law of thermodynamics is a system entropy approaches a constant value as its temperature approaches absolute zero. This is basically the laws of thermodynamics that apply in our daily life. As I said before, I will emphasize more about the second law of thermodynamics. Second law of thermodynamics asserts that energy has quality as well as quantity, and actual process occurs in the direction whereby the quality of energy is decreasing. For example, if we put a hot coffee in a cool room, the heat will flow in the direction of decreasing temperature, which means that the heat from the hot coffee will flow out to the environment that is cooler than the coffee. That is some basic application of second law of thermodynamics. Firstly, I will explain a bit about the structure of electric kettle. This is electric kettle and this is its power supply. To use the electric kettle, we need to put the electric kettle into this part and put the power supply into the switch, and then we turn on the thermostat and it will stop when the water is at certain temperature. Inside this electric kettle we have a iron coil to supply heat into the electric kettle. We also have the thermostat that stop the water boiling at certain temperature. So, I know you wonder how does the second law of thermodynamics is applied into the electric kettle. Second law of thermodynamics states that the total entropy of an isolated system can be never decreased all over time and is constant when the processes are reversible. So basically, the processes in this electric kettle is reversible. When you switch on the electric kettle, the electrical energy will supply into the electric kettle that is received by that's received by heating element, which is an iron coil. Then iron coil change the electrical energy to heat energy so that the water inside the electric kettle is boiled. The boiling will stop when the switch or the thermostat is switched on. So when you leave your water kettle without any power supply to it, the temperature inside this water kettle will decrease because the heat energy will absorbed by the surroundings, which are in lower temperature compared to the electric kettle. Thus, this is where the process is reversible between the temperature of the surrounding and the water kettle. So this obeys the second law of thermodynamics. Now, we know that thermodynamics is applied in almost everything in our daily life. For example, electric kettle. We can use electric kettle to make our coffee in the morning. So, as a conclusion, thermodynamics is really the science of energy. Thank you for watching. See you.